So first, I wanted to just reiterate the mission and vision of CBTN. The Children's Brain Tumor Network is dedicated to driving innovative discovery, pioneering new treatments, and accelerating open science to improve health for all children and young adults diagnosed with a brain tumor. By accelerating the pace of transitional research and the discovery of new treatments, we are a global community with a shared goal to save children and young adults from brain tumors. Now, these were just reworded last year, the year before, but this is something we've been driving for years since inception of CBTN. So it just really better encompasses what we do on a daily basis. But always good to refresh and reread those mission and vision statements. But I do want to note that it all started with two men and a doer. It's quite the story, and I think if I told it, I would not do the story justice. So perhaps Dr. Resnick or Dr. Storm can tell you at a later time if you haven't already heard the story. It's really great. But we know that, hold on. What started with two men and a doer has grown into the world's largest pediatric brain tumor resource. It begins with our patients. And at this point in time, we've enrolled over 3,900 patients from around the world. So we are enrolling in Italy and Australia, and we're furthering our international efforts every day. What we do bring in is clinical data, and we take the specimens that we're receiving from surgery, and we are comprehensively annotating them with clinical data. It's very robust clinical data, and it starts with demographics and medical history, predisposition. We, of course, do the diagnosis and treatment information, and a longitudinal follow-up, which makes it additionally unique in that the coordinators and the research assistants are going into the EMR, as Brian mentioned, and pulling out how the patient's doing, the status of the tumor. If they do have a recurrence or progression, then we are capturing that information all over again, as well as the specimens from those surgeries. We are also bringing in reports to add to that robust resource, pathology, operative reports, MRI reports. They're all redacted and available for the researchers. And then MRIs is our newest endeavor to bring in MRIs from from prior to surgery, after surgery, the longitudinal follow-up, especially for our low grades. We've started with CHOP subjects, and we are well on our way to almost completion of those. They're all being placed into a platform called Flywheel, and we are now turning towards our external consortium partners to bring in those MRIs as well. So whatever possible resource we can find to put with these specimens, we're doing that. So stay tuned for something new tomorrow. There's always something new. And of course, we have 30 different diagnosis types and growing in the biorepository and clinical data. And this is always changing because we know with the molecular profiling of these tumors, there's more than 30 different types in there, especially with medulla having the 4 different subtypes. So there's a lot more molecular information in there as well. And then I just want to note that this data, the clinical data that we're pulling into the systems, is very critical from deciding the cohort for scientific projects, supporting downstream analysis, survival information, contributing to the diversity projects that Cassie will talk about later. And then, of course, ultimately, what's fantastic is using this information as a control group for clinical trials rather than the patients themselves. So all of this information, especially the clinical information, is accelerating the research. Okay, and started with our patients, continues on with the specimens. At this point in time, we have over 45,000 specimens that have been collected, processed, and then ultimately shipped back out to the researchers for their projects. We've generated multi-omic data on over 1,000 subjects, and we're going to continue to do that as we are able with support from the NIH and other grants and additional funding. This includes, or all this information has been put into the Pediatric Brain Tumor Atlas and includes whole genome sequencing, RNA sequencing, methylation, and proteomic data. All of this information is allowing our researchers to see the mutational targets and identify existing treatments for the precision medicine approach, or even returning to the bench with the corresponding specimens to work on new therapeutics, including immunotherapy. So we're going to take those specimens up another notch, so we're working on cell line generation. At this point in time, about 100 have been created or are in progress. And cell lines, unlike the specimens themselves, are a renewable resource, so they're not depleted. We can continually generate more passages to continue the research for our efforts. Again, more than 30 diagnoses have been generated in cell lines, and they've been used in 31 projects. So 31 projects, researchers have requested those cell lines, so that we are in progress of either delivering them, they've already been delivered, or we just received the request. We are also generating PDX models from those tumors. We've had 6 created, and they're being used in 3 projects. They haven't yet been shipped, but they are on their way out the door in the coming weeks. Organoids is another thing that we embarked on last year, and noting that this was June of 2020, right in the beginning of the pandemic, but we were continuing our research efforts. So we started this at CHOP, requires fresh tissue from surgery. And at this point in time, 10 have been created, and they still need to be characterized, but they're coming soon to the researchers as a resource. They're just not quite yet available yet. So these models that are generated from these tumors can be tested against therapeutics in a controlled environment, or something like the CRISPR drug screens to evaluate the effectiveness of current therapies. So that is the addition of our specimens. And all of these efforts, the clinical data, the specimens, the omic information, are all supported by our research platforms, the NIH Kids First portal, Cavatica, the Pediatric Genomic Cloud, PEDC Bio portal, which is already analyzed omic information, and then of course Flywheel, our next platform that we've just started using with the MRI imaging. So these platforms are allowing researchers from across the world to access and collaborate and communicate with one another, and just fueling that discovery between them, ultimately helping our children. Our latest numbers, always something to be super proud of for us. We've supported over 600 researchers worldwide, 145 submitted data projects, as well as 94 specimen projects. I mean, that's phenomenal. It's not just one researcher, one lab, specimens going and sitting in a freezer until they can find funding. We have supported well over 200 projects, and we're going to continue to go, to continue to march on and support more and more researchers until, again, we help our kids. And then connecting to the hallmarks, I have all of them listed, and the number following the different hallmark are the projects that are actually investigating that specific hallmark. So they're all listed. So we've gone, all the way up to 19 with the first hallmark referenced. Okay, and another thing I wanted to highlight is that we didn't stop, and we never will stop. So this graph represents the enrollments over time by year by our sites that they contribute. So if you could see, I don't know how big it is for everyone, but 2011, that's where CHOP started contributing to the biorepository. And then you can see over time, we've added more and more sites. And it's not a comprehensive list of sites here, because not all are contributing specimens or have been onboarded at this point in time. But these enrollments, you can see year after year, each site is contributing. But what I want to highlight specifically is this particular year, and that's 2020. Obviously the pandemic came, it started hitting us in March. labs were being shut down across the country, across the world. But you can see here that even in the light of a pandemic, all that was happening, we didn't stop. Our sites, our consortium partners, they did not stop enrolling. They did not stop collecting specimens. We were still able to bring in that information even in light of a pandemic. So again, highlights that we're going to keep going for our kids. Okay, and some key takeaways of just what I want to highlight. We're going to continue to change the research landscape, accelerating the pace of research, having open science so researchers are able to access this information fairly rapidly. They can access it today, which is what's key. They can log into PC Bio Portal and see the data today, not tomorrow, not in 10 years. They can access the specimens, they can submit for a request, and we're going to evaluate that request over the course of just a few weeks, and then get them their samples as soon as we are able to get them extracted and shipped. Raw genomic data, they can submit today, and they can actually be doing some analysis on that PBTA next week. So that's just a matter of days to review their submission and get them access. So again, acceleration and open science is what's key. I mentioned this earlier, we are supporting endless labs and projects, not just one, with all of these institutions coming on board and agreeing to send the specimens and contributing cell lines and data in one spot, just is accelerating the pace of research, providing the rarest tumors all in one spot, rather than having one tumor here and two tumors at another institution. We're growing each number of diagnosis every day. And then again, as I mentioned, the development of clinical trials and precision medicine through collaborations. We've been working with PNOC. It's been mentioned on other calls, the PNOC OA trial, where we are contributing with our research genomic sequencing data to the clinical data that's generated in the pathology labs that are CLIA certified, and collaborating with that PNOC trial to better determine the best therapy for that patient to go on. And of course, empowering the rare, that's what we do with brain tumors being rare. And then of course we have the rarest of the rare, like ETMR. We've embarked on a collaboration with Dr. Derek Hansen at Hackensack to bring in embryonal tumor with multi-layered rosettes, if I can say that correctly, ETMR samples. It largely impacts our children that are under 2. So we're actually working to get those samples in from even non-consortium members to drive up the numbers there. We're working with NF2 Biosolutions for our patients that are diagnosed with NF2, as well as the Chordoma and Oligonation Foundation. So again, empowering the rarest of the rare is what we are doing. So again, we aren't going to stop. We're going to continue doing this, continuing to bring in specimens, data, generating all those models and sequencing so that we can help our children and ultimately save their life. The last thing I wanted to address, and I don't know how much time I have left, just want to highlight our unsung heroes in our research CBTN world. These are the clinical research coordinators, our assistants and specimen techs. They are truly doing the heavy lift. They are doing, I don't know, I think Angela always says boots on the ground, the day-to-day regulatory and the IRB, that's working with the institutional regulatory board at their site, submitting the regulatory, getting it approved, getting the consent approved, making sure the consent has the appropriate language so it can be understood by patients and their families, doing the actual consenting. And the coordinators at each site, they're not just stepping outside their office door and going and turning and consenting. They're actually leaving that building. They are getting on a shuttle. They're going to the main hospital, or they're walking 5 blocks to get to the research building or wherever they need to go to consent. So there's a lot of movement. I've been to those institutions, and even at CHOP, we are in different buildings now. So it's a lot of physical change too for them. Data procurement, like we mentioned earlier, a lot of EMR, the electronic medical record extractions and follow-up, going in and updating that data on a regular basis. Preparing the shipments and the manifests that are coming to us, either monthly, bi-monthly, or quarterly. It's a lot of information that they are providing back to us, and a lot of operating procedures that they are having to follow to ensure the integrity of our samples are met, as well as getting all the information that we are then subsequently providing to the researchers. And then, of course, quality control. So it's going back to that. They're double checking the shipments and the data, and then we're double checking it. So, and we'll go back to them with questions. So there's a lot of back and forth between operations and the sites, so that we can, have some really great data that's going to the researchers. And I just want to list them all here, just to show you. Here they all are. There's a lot of them because we have a lot of sites, but I truly appreciate all that you do. You are truly what's putting all this together. You have given a lot to the network and ultimately to the children. So thank you to all the coordinators, techs, and assistants. Thank you very much, and that's it.
Thank you, Jen. There's one question in the chat from Kristen Gillette. Has the increase in data collected by the CBTN to offer to the community minimized the need for actual specimens to be shipped to use in research?
Go ahead, Jen.
Okay, no, go ahead, Adam.
Yeah, no, I think it's an awesome question and very relevant. Yeah. And it turns out my sense is it's just the opposite. And part of this has to do with the fact that each time you generate one form of data modality and convert it into, let's say, a whole genome sequence or RNA-seq, invariably that creates the need for asking additional questions. So some of the things that you'll note in our efforts is, as we began with foundational layers of whole genome and RNA-seq, on top of each one of those, we've now initiated smaller pilots of proteomic data generation, single cell data generation. Each one of these modalities or technologies provides a different lens on what's taking place inside the tumor. And it's assembling those different lenses that essentially empowers new interpretations. So it's almost like, seeing the scene of an accident from multiple different perspectives to better understand actually what happened or what is taking place. And so invariably what happens is that each time we generate a layer of data, more requests come in, more technologies want to be applied. I suspect that's going to continue because the rate at which new technologies are emerging is only increasing.
Great, thank you, Adam. There was also another question in the chat, which was answered, but I'll just sort of read the question and answer so that everyone is aware. If I can scroll back and find the question, I found the answer. Basically, the question was, have we been able to keep up in regards to large data generation sequencing of the specimens that we have? Here it is. Curious as to what the backlog of specimens is that has not been sequenced. Have we been able to keep up? Adam answered, unless you want to answer it again, I'll read your answer, Adam. I said, currently we've generated some form of sequencing and molecular data on approximately 25% of the samples, so still more work to do. However, we've recently initiated pilot efforts sponsored by the NCI that have supported additional data generation across new data modalities. We're also hoping initiatives like CCDI and Kids First, both of which you're going to hear about today and tomorrow, will expand such opportunities. So I think that actually is along the same vein as what you were just talking about, Adam, as well.